Hi, in this tutorial video I'm going to talk about the new features of PSIM version 10. The first thing you'll notice is maybe there's an inlaid simulation results inside of the simulation here. The second thing, also there's this project view on the left hand side here. First study is showing the hierarchy of my subcircuits in this particular schematic, and also all the simulation results down here. And the next thing you'll notice also is there's a library browser docked on the left hand side now. And I'll talk more about the new devices now. So I'll just open up a new file and let's pull up some of the new devices. So I'm browsing in using the library browser here. I'm going to pull up a resistor, an inductor, a cap. I'll also pull up the electrolytic cap as well. I'll drop down and go into the switches now and pull up the diode. And I'll now dive down and grab the 3-state MOSFET. Put that up as well. Additionally, I'm going to go into the thermal module here, bring up the inductor model for the thermal module. I'm also going to go into the renewable energy module, and I'm going to bring up the new solar panel models that we have here. I'm also going to pull up the new ultra-cap model that we have. Lastly, I'm going to come down into the IC models here. And we can see there's a 5.5 timer IC here, but I'm also going to come in and just pull up one of these PWM ICs, and I'll also pull up one of these driver ICs as well. Okay, so this is pretty much the suite of new models that are in PSIM version 10. What's new about the resistor? Well, the resistor, inductor, and cap all have now a level 2 aspect. So we can go to level 2 on all of these devices now. And that allows us to easily model the parasitics associated with these devices. So level 2 has a whole host of things. In the capacitor here, we see there's an equivalent series resistance, inductance, some leakage associated with it. We go into and look at the inductor, some parallel resistances and capacitance. And the same with the resistor, some equivalent inductance, equivalent series inductance, and some parallel capacitance. So very easy for us to drop all of these values into the simulation. Previously in PSIM with the ideal devices, you had to, if you wanted to add in a parasitic, you had to go and grab another device from the library and put it into the proper configuration of the circuit. The next thing to look at here is the diode. The diode now, if we go to level 2 on the diode, it has a reverse recovery characteristics associated with it. These parameters here, I'll just bring this over into the middle here. These parameters here, to figure out what to put in here, if you go to help and then tutorials, there is a diode with a reverse recovery model PDF that will help you determine what these characteristics are. So this switch now is non-ideal and models the reverse recovery effects. Coming down to the MOSFET now, if we go to level 2, we can now drive this with a real voltage source, and we can look at the real, so the transition from on to off and off to on is now possible to look at in detail with PSIM. So we can look at the on and off transition and the amount of energy used to turn the device on. So we can look at the energy flowing into the gate on this device as well. Further on the subject is with these PWM ICs and this driver IC, if we go and we can use these to drive this device, this level 2 device. So if we go to level 2 here, we can drive that device, or we can just set up this driver IC as well and use this to drive this device. So we need to drive this MOSFET with, a voltage source, be it plus 15, minus 5, or whatever we want really. The next thing to comment on is this inductor model, which is in the thermal module. So what this thermal module does is there's 2 nodes at the top here, and these are giving us thermally dependent copper or core and winding losses. So to edit those, just go into the device database editor here, and we can look at the inductors in the library. So if we look here, we see the power losses versus the peak flux density here. And we can also look at the power loss versus temperature here. So we can add all these in to define our own inductors, bring in our own different manufacturers' information, and we can choose between core, winding, gap, all these sorts of things, and build up our device. The next to look at are these two new solar panels. Both are built off the EN50530 standard, and both use sunlight intensity and temperature inputs. And you can look at the help file for more information on these. Also now there's a new ultra-cap model. So to get these coefficients here for the resistance, etc., you just need to go in to the utilities menu here, and again there's a ultra-cap model tool, and this will allow you to extract the curve and bring it in properly to the simulation. Let's close these out. So now looking at the simulation here, I can drag and drop any of these other simulation results into this simulation. Let's just zoom in here, and we can look at, say, and we can look at the ID versus the reference. So there's ID. If I double click on this, I can pull up the reference as well. So we'll see both those on the simulation there. So also if I print, these things will be printed as well. So if we wanted to print this out, we could do that as well. And then also what we see is there's a hierarchy here. So the top level one here is I've got my big, I've got my boost PFC on the front end driving my DC bus, and then I have a motor being driven. So we can see here various circuits and sub-circuits are listed, and we can browse and look at all of them in turn. And then we can also look down here at the parameter file that's associated with this circuit. And if there are multiple parameter files associated with multiple sub-circuits, you could see that hierarchy as well. The next useful feature that happens with this is we can come up and we can right-click on this and say Create Study Copy. So then we just select the circuits that we want to create a copy of, and we can come in here and give it a name. So Study 1. Or whatever name you like, hit OK, and then what happens is we see this new study circuit has been made down at the bottom here. So we see now that there's now a study circuit for all of these. So what we can do is we can edit these now. So PSIM's automatically copied all the appropriate files, and we can edit and change things around and do things in the circuit while keeping the main first version safe. So we can make edits and not have to worry about and being able to backtrack. Okay, so the next thing I'd like to highlight here is we also have a new AC sweep simulation down here ready to go. In this simulation, what we see is it's multi-sign. So PSIM, when we run an AC sweep in PSIM, previously what would happen is you would run 50 separate simulations at between 100 and 60 kHz. So PSIM would space those out, and you'd get your AC response that way. So you'd have this perturbation frequency here, and you would pick up the phase and amplitude difference up with the AC sweep probe here. Now with the new AC sweep, you just select when the steady state time is. So we run the simulation and look at what the steady state time is. So we see that we hit steady state around 2 milliseconds. That's nice and safe. So what we do is we take that value in, and we put that in here, so 2 milliseconds, and we choose about 10% of our reference. We put that in there, and then we run this AC sweep. Then we'll get AC sweep results pretty quickly here, and it'll still preserve the switching frequency here. So we can see here I've got the analog response, and I've got the digital domain response. So if we were to implement a digital controller, we'd use this the blue line. So we can see that's how that's set up here. And we saw it was done in about 4 seconds. If you have experience with previous versions of PSIM, you'd know that this would have taken a little bit longer than 4 seconds, especially if you started to get into lower frequency responses. So let's quick look at that. Next up is we can look at the parameter sweep. So I've got a simulation here. So we can sweep now frequency, resistance, capacitance. Any value that you can input in PSIM, you can sweep. So we could even come in and sweep the level 3 MOSFET parameters if we wanted to. So in the 3-stage switch, if we went to level 2, we could sweep all of these parameters as well. So here's a quick look at the simulation results. We can see The first run is down here at 1 frequency, and then we see that we're incrementing the last one, the last parameter here, which was the capacitance. The second parameter is being held constant, and we can see first frequency, second frequency, third frequency, and fourth frequency here. And it's easy to see which run you've done based on the numbers here. So parameter 1, run 4, parameter 2 is at setting 1, and the last setting, the last parameter is at setting 4. You can see which ones are which when you pull this up, and you see that's what's going on there. So that's a quick look at the parameters. So here's a look at these devices and the new devices in circuit here. So here I have the level 2 MOSFET, and we can see the simulation results here. I've also got the level 1 diode going right now, and this is the ideal MOSFET, and we can see what's going on. If I pull up the simulation results as well, we can also look at the gate current, and what else we can do is we can look and maybe zoom in on this transition here, and we can see if we add the data points, you can see that it's actually been, that transition has been simulated, whereas if we just quickly overlay the ideal switch on, we'll see that that was in fact an ideal transition. When we look at this transition, it is in fact an ideal transition. But one of the nice things that I'd like to highlight here is if we go and change this to a level 2 device, introducing reverse recovery and some parasitic inductance and that sort of thing, if we run this simulation, the waveforms, we get a really good idea of what is going on in terms of conducted emissions. So let me just delete some of these screens here and clean this up. And what I'm going to do is I'm just going to delete this, so we just have this, and I'll also get rid of the markers. So here we have the conducted current, so the current we're drawing from the source. So from here, if we run the FFT and we change the axis and we change this to dB microvolts, we get a really good idea of what our conducted emissions will be. Additionally, with PSIM, this was not a new feature, but a much more useful feature now. So we can add in a standard and look and see what our odds are or what problems we need to fix in order to be able to pass the first stages of emissions testing. Okay, so that's it for this tutorial video on the new features of version 10. I will be producing tutorial videos going over some of the new features in more detail in upcoming videos. Thank you so much.